Good morning, students. Welcome to our next topic, electricity. We hope that you might have watched the previous video on motion. If you had done it, you could have got a basic idea about motion. Also, you might have got an idea of who created this motion. Now we will be moving on to this topic, electricity. If you completely see this topic, you will get a basic idea on electricity. So let's go into the topic in brief. Electricity has become an essential part of life in the modern world. In almost all the sectors, it's been used to make life faster and easier. An unseen energy has changed the world from muscle work to machine work, which is electricity. So let's see what's the definition for electricity. The flow of electron in a specified path is called as electricity. Iron box, fan, television, mobile phone, computers, oven, etc. all require electric current to operate. Also in the future, the automobile industry is also planning to go fully on electricity instead of fossil fuels. So the future world will be carbon-less greenhouse with electricity. Next, let's see about electric charge and current. First, we will see what's an electric charge. A charge is a physical entity that is defined by excess or deficiency of electrons on a body. This electric charge can be classified into two types, negative charge and positive charge. A body is said to be negatively charged if it gains electrons. For example, when an ebonite rod is rubbed on a fur, a negative charge is acquired. A body is said to be positively charged if it loses electrons. For example, when a glass rod is rubbed with a silk cloth, positive charge is acquired. The total charge which is then acquired inside a body is an integral multiple of the magnitude of charge on a single electron. This principle is called quantization of charge. We can calculate the number of electric charges accumulated by means of the SI unit coulomb, capital C. The magnitude of charge on one electron is E equals -1.6 x 10 to the power -19 coulomb, C. The charge on n electrons, Q equals Ne equals Nx 1.6 x 10 to the power -19 coulomb, C. The magnitude of charge on one proton, E equals +1.6 x 10 to the power -19 C. Next we will see about electric current. It is defined as the rate of flow of electric charge through any cross-section of a conductor in an unit time. So the amount of work done in moving the electron stream is known as electrical energy. This electrical energy can be converted into other forms of energy such as heat energy, light energy, etc. For example, in a computer, the electricity is given as input, which gives out light, heat and sound energy. Similarly, the electric energy in a bulb is converted into light energy and heat energy. If Q amount of charges flows through a conductor in T time, then electric current I equals charge Q divided by time T, since Q equals Ne, I equals Ne divided by T, where N equals number of electrons flowing through the conductor. The SL unit of electric current is ampere, denoted by the symbol A, named in honor of André-Marie Ampère, a French scientist who lived in the period 1775 to 1836. It is a scalar quantity. When 1 coulomb of charge flows through any cross-section of a conductor in I second, then the electric current flowing through it is said to be 1 ampere. That is, 1 ampere equals 1 coulomb divided by 1 second. Smaller units of current are represented as milliampere, microampere, etc. Now we will be seeing about the direction of electric current. The direction of electric current is taken in opposite to the direction of the flow of electrons, that is negative charges. In an electric circuit, the current flows from positive terminal of the cell to the negative terminal of the cell. The flow of charges occurs inside the wire which is connected between the positive and negative terminal of the cell. Inside the solid, the atoms are closely packed, but the electrons are able to travel through the solid crystal as if they were in vacuum. When a steady current flows in a conductor, then the electrons in it moves with a certain average drift speed in the order of 10 to the power -4 meter per second. Thus, flow of charges, i.e. electrons, produces current in a wire. Drift speed is the constant speed of the electrons inside the conductor with which they move under the effect of external electric supply. So, in order to measure this current which is flowing, we need to have an instrument called the ammeter. Ammeter is a low resistance device that is always connected in series with the device through which the current is measured. So to conclude, let's see the definition of the key terms once again. The flow of electron in a specified path is called as electricity. An electric charge is a physical entity that is defined by excess or deficiency of electrons on a body. The total charge which is then acquired inside a body is an integral multiple of the magnitude of charge on a single electron. This principle is called quantization of charge. Electric current is defined as the rate of flow of electric charge through any cross-section of a conductor in an unit time. Drift speed is the constant speed of the electrons inside the conductor with which they move under the effect of external electric supply. Hope you might have got a basic understanding on the topic electricity. If you couldn't understand in the first attempt, don't worry, again watch the video 2 or more times, then you will never forget. So stay tuned for the next topic soon, till then goodbye. Thank you.